So we're going to be looking at the new NEXT18 decoders. It's a new interface, NEM662, and as the name implies, it's an 18-pin connection. The beauty of it is it's very, very small, and you've got lots of electrical connections for individual functions. So this is the blanking plug out of a loco, and that's the actual interface. Another nice thing is that it's very difficult to get it wrong. It either goes in or it doesn't, and the manufacturer will make it absolutely clear what the orientation is going to be. So the Lenz 10318-01 Silver NEXT18 is this little decoder here. It has railcom signal, it has ABC braking, and it has the normal motor control features that we expect of Lenz. There are also 4 functions with the possibility of another 4 smaller functions. So there's 4 with 200 milliamp outputs, and then there's another 4 with just 2 milliamp outputs. Again, it's the kind of interface that only a manufacturer is going to be fitting these functions, so the 2 milliamps we'll leave to their discretion to use. That's the decoder lined up, and it just clicks in. Very nice and very positive little fit. So here's the loco reassembled. We've just got directional headlights on this particular model. The decoder performance is as smooth as we expect. And this is straight from the factory settings without changing any of the inertias. Should be able to crawl along. It becomes the mechanical limitations of the loco for the minimum speed. So this is a small loco with just directional headlights. I'll look at something a little bit larger in a minute. So this rail bus has a couple of extra functions. So we've got the interior lighting there and destination boards all going through the decoder. Again, the NEXT18 decoder drives really smoothly. There's interior lights there. Now connected the Lenz Silver NEXT18 to a test rig. And this allows me to show all of the function outputs, or majority of the function outputs anyway. So if we put on loco lights and the direction change there, so that's outputs A and B. And from the factory, output C is on function 1, output D is on function 2, output E is on function 5, and output F is on function 6. They can be function mapped, and the manual will explain how to do that. So there are a couple of other functions already pre-programmed onto the decoder. So function 3 will halve the speed, so shunting speed. Function 4 will turn off any inertia, so you'll see that the motor just stops, and accelerates up very quickly. So if we turn function 4 off, you'll see that the motor now accelerates much more smoothly based on the inertia programmed into the decoder. So the decoder supports programming on main, and I can probably demonstrate that best by looking at acceleration inertia. So if we accelerate up, you'll see that the motor accelerates quite quickly on my commands. So if we go to programming on main and CV3, which controls acceleration inertia, and put in a large figure, so I'm going to go through CV350 and send. Come back out. This time when I throttle right up, you'll find that the model accelerates on a much slower scale, so there's a big acceleration delay. I haven't changed the braking delay, so that will come down. The decoder can also be programmed and read on a programming track, so I've now connected up to a programming track. If we go to programming there, firstly if we look at the address, oops, and read that, it's reading the address. It will do a 4-digit addressing, so we clear that, we'll program it a 4-digit address, and if we read it back again, you'll see that that 4-digit address there. You can modify individual CVs on here. A handy CV to be able to read is CV30, so CV30 stores an error code, and you want to be seeing a 0 anytime you read that. Any other number, then yes, check out what the fault is using the manual, and don't put it on the main track if there is a fault code in there. You can do a reset in CV8 and give it a value of 33. So that will reset the decoder back to manufacturing defaults. CV8, if you read it, should read 99, and that is Lenz's code. The programming manual comes in English, and there is a full list there of all the CVs supported on this decoder. In reality, we don't change very much. If you want to go in, do advanced programming, there are full instructions here how to do it. So I'm just going to quickly demonstrate the brake generator function on the decoder. So I've programmed in CV51 for a ABC braking with shuttle and a 4-second delay. So we'll start it running. You can see the throttle there. As I go into the brake section over here, you'll see that the motor slows down and stops, the direction changes, and then after 4 seconds she'll start running again the other opposite direction. Let's stop that now. I've fully covered ABC braking in another section on our website. It's something worth looking at. You can set it up so that the decoders will stop in front of signals, and when the signal goes back to green, the locos will set off again. Or you can set it up as a simple shuttle where it will go from end to end, stopping at each end and waiting for a programmed length of time. All of that is covered in the manual under ABC braking, but as I say, I've done a large volume of work on ABC braking on our website. So this has been a quick introduction to the Lenz Silver NEXT18 decoder. Manufacturers are adopting this interface because, unlike the 6-pin decoder, it's a very positive fit. It's quite difficult to put it in the wrong way round, and it allows them to use many more electrical connections, so it much more functionality in terms of lighting and other electrical equipment on locomotives. Fleischmann have just adopted it on their latest electrics, the 145s, 146s and 185s, and Graham Farish are putting it in their Newcastle class, and Liliput have been pioneering it for the last 5 years in a number of models.